class, we will discuss some good questions of GOC. So let's start our question number 1. So question number 1 is that in the given pair, we have to identify most acidic compound in A and B. In A and B, we have to find out most acidic, and in C and D, we have to find out most basic compound. So first of all, we are solving the A. Which carboxylic acid will be most acidic? So we know that CH3 group is present on ortho position of carboxylic group. So we all know that this CH3 will show ortho effect. Ortho effect. So what is ortho effect? According to ortho effect, when any group is present at ortho position of carboxylic acid group of benzoic acid on benzoic acid at ortho position, if any group is present, that group may be electron withdrawing group or electron donating group. Any group if present, then it will affect the planarity of that CWH group. That's why it will increase the acidic strength of benzoic acid. It means if any group is present at ortho position on benzoic acid, then its acidic strength will be always more acidic. So due to that ortho effect, the second is more acidic. In compound B, there is no conjugation because we are not taking phenyl ring. That ring is cyclohexyl ring. So we just take the plus I effect. So if we consider the plus I effect of CS3, then CS3 will increase the electron density on carboxylate ion. So it will destabilize the carboxylate ion. So carboxylate ion will not form easily. So we can say the second will be less acidic and first will be more acidic. Then in compound C and D, we have to find out most basic in C and D. So C and D, most basic. So there is a CS3 group. Now at amine or at aniline, if any group is present at ortho position, then again it show ortho effect. But now this time, what is the ortho effect? The basic strength of amine is decreased due to ortho effect, because if any group is present at ortho position of on aniline, then this nitrogen atom cannot donate its electron easily due to steric hindrance of the group that is present at ortho position. That's why its basic strength will be decreased. So which one is more basic? First. In second, there is no conjugation. So we will consider only plus I effect of CS3. So if we consider the plus I effect of CS3, then according to plus I effect, CS3 group will increase the electron density on nitrogen atom. So that nitrogen atom become more basic. So second is more basic. So what will be our answer? In A there is second, and in B there is first. In A there is second, B first, C first, and D second. So our answer will be D. So that is our final answer, D. Then second question. The question number 2 is that select the response that correctly identify the number of carbon atoms of each type of hybridization in the compound given below. It means we have to find out how many carbon here have sp3 hybridization, how many have sp2 hybridization, and how many carbon have sp hybridization. So just find out the hybridization of the carbon. This carbon have sp2 hybridization. This is sp hybridization. This is again sp2, and this carbon is again sp2. So hybridization we can find out using the formula of steric number. Steric number is equal to sigma bond plus lone pair. So using this formula we can calculate the hybridization. So how many sp2 hybridized orbital are there? 3. And how many of sp? Just 1. That one is only sp. Another 3 carbon are sp2 hybridized. sp3 is 0. So our answer will be C. Then come on next question. What is the next question? Let's see. The circle represent most basic atom in these molecule. Which of the following is correct? It means we have to find out the most basic nitrogen atom in the given molecules, and according to the question the most basic nitrogen atom is circle, and we have to find out, as in the question the circled nitrogen atom is most basic or not. So just find out. Let's see. There is two nitrogen atom in first molecule. On both nitrogen atom there are lone pair, but these lone pair are in conjugation with pi bond. So these lone pair cannot be donated easily. But here is pi pi and pi lone pair conjugation. We know if there is pi pi as well as pi lone pair conjugation, then pi pi conjugation become dominant. So these lone pair are not in the conjugation. They are not in conjugation. Not in conjugation. So circle nitrogen atom lone pair are not in conjugation. That's why circle nitrogen atom in compound A can be donated easily. That's why it is correct. Means circle nitrogen atom in A option is correct. It's more basic. Then let's check B option. In B option there are two nitrogen atom. Let's see, that is 1 and that is 2. So one nitrogen atom have lone pair that is in conjugation with benzene ring or phenyl ring. So the lone pair present on first nitrogen atom cannot be donated easily because they are delocalized. But on second nitrogen atom lone pair are localized. So the nitrogen atom, second nitrogen atom can easily donate its electron. That's why second nitrogen atom is more basic. So option A is correct as well as option B is also correct. Option C, there are 1, 2 and 3 and 4. 4 total nitrogen atom. The first nitrogen like that first, second and third. Then fourth. First nitrogen atom lone pair are in conjugation with carbonyl group. So we can say these are delocalized. So cannot be donated easily. Second and third also, they cannot be donated easily because they are in conjugation. But that one, that is suppose third or circled nitrogen atom, that circled nitrogen atom lone pair, correct, these lone pair actually, these lone pair can be donated easily. So it can donate easily because the circled nitrogen atom is not in conjugation. So the circle nitrogen atom here also is more basic. So C option is also correct. So our answer will be all of these. Answer is D. D is our answer. Let's see next question. So next question is that arrange the following in decreasing order of acidic strength. Okay, let's see how we can solve it. It's very simple. First of all, we have to understand the order of electronegativity. The order of electronegativity. Electronegativity order. So O positive, then N positive, then O, and then N. That is the electronegative order. So O, when positive charge occurs on O atom, it's most electronegative. That's why it will attract the electron of sigma bond between O and H more faster than all other compound. That's why it release H plus ion very quickly. So most acidic is the A. Then N plus. It can easily attract the electron of bond of N plus and H. So it will donate the H plus ion. So first one is A and second is D. So first is A and then D. After that, the order of electronegativity is oxygen is more electronegative. So it will accept the electron more easily and release the H plus ion. So then C. So first is A, after that D, after that C, and at last there is P. So answer will be C. So we can solve it according to electronegativity. Let's see another question. The correct order of heat of combustion of the above compounds means we have to find out the order of heat of combustion. We know that the heat of combustion is directly proportional to number of carbon atom. So heat of combustion is directly proportional to number of carbon atom. So we can say number of carbon atom in third compound are 5. Here 5 carbon. After that there is 4 carbon. Then there is 3 carbon. So third is the have most heat of combustion. After that second, then first. So answer C will be correct answer. Let's see another question. Compare the carbon-carbon double bond rotation across A, B, C. We all know double bond never two carbon if two carbon have double bond, pi bond. If two carbon have pi bond in between them, then they can not rotate. There is restricted rotation due to presence of pi bond. But if this pi bond can convert into sigma bond plus and then minus. So these carbon can rotate. So we have to find out which of the compound pi bond can convert easily into sigma bond. Let's see. If pi bond electron we shift towards this ring, so there will be negative charge and there will be positive charge. So our compound A will become like that. There is positive charge and there is negative charge. And we know these two rings are aromatic in nature. That one is aromatic and that is also aromatic. So both rings are aromatic. Then if we observe, so that is the first compound. If we observe second compound, then what happened? This negative charge will occur here and positive here. On larger ring, there will be positive charge. So our compound will be like that. Like that. So there is negative charge and there is positive charge. Larger ring, there is positive charge. So we can observe that ring is aromatic and that one is also aromatic. It means we are getting again two aromatic ring in compound B by shifting the pi bond. So we can say there is also aromatic compound, so it's also stable. Let's say there are larger rings or we can say more delocalization. So B is have more aromatic character than A. So B is more stable than A. If we consider the C compound, on C compound there will be negative and there will be positive charge. So we can say suppose there is positive charge and there is negative charge. So one ring will be aromatic but another ring will be anti-aromatic. So one ring will be anti-aromatic and another one is aromatic. And we all know that anti-aromatic compound are most unstable compound. So that's why we can say order will be B, after that A and then C. Why we are taking B? Because in B there is more conjugation. So aromatic character will be more. So stability will also more. So answer will be B, A and then C. Let's see next question. Which of the following acid have stronger conjugate base? We all know that actually strong acid have weak conjugate base. Strong acid have weak conjugate base and vice versa. Means weak acid will have stronger conjugate base. Stronger conjugate base. So we have to actually find out which one is a weak acid. So in compound first H2S and H2O. H2S and H2O. So which is weak base? So we know that weak acid, sorry, we have to find out which one is weak acid. So H2O is actually weak acid. So its conjugate base will be strong. It will make OH negative and its conjugate base will be SH negative. And we all know that the size of atomic size of oxygen is lesser than sulfur. So sulfur is actually due to bigger size handle negative charge on it more easily, but oxygen has smaller size, that's why it cannot handle the negative charge on it easily compared to sulfur atom. That's why oxygen will release its negative charge more faster. So we can say it is a stronger base, or we can say OH negative ion will react with H plus ion more faster. So it is a stronger conjugate base. So we can adopt any two approaches. We can check which one is a weaker acid. H2O is the weaker acid, that's why its conjugate base like OH negative, that will be stronger. Second approach is that we just find out which are the conjugate base. So conjugate base of H2S is SH negative and conjugate base of H2O is OH negative. Now we can check their basic strength. In a group, when we are observing in a group, then we always remember then the atomic size is the governing factor. If atomic size is lesser, then it cannot handle the charge on it, that's why it want to diminish its charge. So OH negative charge is present on oxygen atom, that is smaller, that's why it cannot handle its oxygen negative charge, that's why it want to diminish its negative charge very easily. So we can say actually OH negative will donate its electron, or we can say it will react with H plus ion faster. So OH negative is the stronger conjugate base. Similarly, there is, if we make the conjugate base, its conjugate base is negative charge on n atom and negative charge on n atom. We can find out this negative charge is in the conjugation of two pi bonds, first pi bond and second pi bond. So negative charge on this nitrogen atom is more stable, that is more stable. So we can say it do not want to lose its negative charge, but its negative charge have only one conjugation, so it will donate its negative charge or lone pair easily. That's why we can say fourth is the more basic in B than compound C. In compound C, when we know the alkynes are more acidic because they have S character, 50% S character, and this is alkene. Here is sp2 hybridization, thereby we can say the sp2 hybridization S character are only 33.33%. 33.33% S character. Now what happen if S character are increased, then electronegativity of element is also increased. So if negative charge on this carbon atom and negative charge on this carbon atom, in the case of alkyne, the carbon is more electronegative because it have more S character. So alkyne carbon can handle the negative charge more easily. So which will donate the negative charge, that is the alkene. So alkene is more basic. Then alkene alkene, the negative charge of double bonded carbon is more basic. So answer will be 6 is more basic. So which is your answer? Answer is A. Next question is that which of the following sigma bond participate in hyperconjugation? We all know that in hyperconjugation, if we have double bond means pi bond, then alpha carbon, the hydrogen of alpha carbon participate in hyperconjugation. Now that is the double bond, and this carbon is alpha carbon as well as this carbon is alpha carbon. So which are alpha hydrogen? Only this one is, and this one. These are alpha hydrogen. So only first and fifth sigma bond will participate in hyperconjugation. So your answer will be first and fifth, B. Let's see next question. Let's see next question is that decreasing the order of acidic strength of different OH group. Okay, so if we are comparing the acidic strength, then how can we compare? Let's see, suppose this OH group will release its H plus ion, then its oxygen will acquire negative charge, its oxygen will also acquire negative charge, its oxygen is also acquire negative charge, its oxygen is also acquire negative charge. Now we have to just find out which oxygen negative charge is more stable. The negative charge is more stable on the oxygen atom, means that is the conjugate base. If conjugate base is stable, so it is more acidic. So which one is the most acidic? So we know the OH group O negative at W, this O negative is in conjugation with phenyl ring, so this negative charge can be dispersed, so it is more stable. So most easily this WOH group will release its H plus ion, so it is most acidic. So first one is W. After that there is 1 degree OH and 2 degree OH. Again that is 2 degree OH. We all know the acidic strength of alcohol group is 1 degree, 2 degree and 3 degree. We can say 1 degree OH is more acidic than 2 degree, then 3 degrees less acidic. So after the W 1 degree OH is X. Now Y and Z, we have to compare Y and Z. Y is 2 degree alcoholic group as well as Z is also 2 degree alcoholic group. But if the negative charge occurs on oxygen atom of Y, then this negative charge can be dispersed due to conjugation. So this negative charge is in conjugation with phenyl ring, so it is more stable. So after the X there should be Y, and in the last there is Z. So W X Y Z, W X Y and Z. So your answer will be A. So these are the top 10 questions or good questions that are based on GOC. Thanks.